Okay, so all of us have learned in the past, in one form or other, the trial and error factoring. So what was the point of that, right? And why do we have to factor? Okay, so visually, in this expanded form, x squared plus 4x plus 4 represents this, an x by x squared, and a 1 by x squared, but we have 4 of those, and if this is 1 by x, right, or 1 by 1 will look something like this. Okay, and the question is, the question of can you factor this? That's the same question as can you use these tiles to form a perfect rectangle, right? Because the point of factoring is to turn this into a product, a number times by another number, which means it's going to be a rectangle. So is it possible to do that with these shapes here? Okay, and we can do that by doing this. See this here? Let's turn that into a horizontal strip. Okay, I'm just gonna erase that and copy and paste this. If I do that, do you see? We just need to fill that right there to create our perfect rectangle. In this case, it's actually going to be a squared. And as you can see, I can slot it right in there and slot this right in there. Okay, so this is going to be an x plus 2 by an x plus 2. So that's why this is an x plus 2 square. And we call that a perfect square. This is an expanded form of a perfect square. Now, see, if you visualize it, even the name makes perfect sense. Okay, and the factoring is always the preferred form because it's an easy way for us to understand what is the size of the number. I mean, it's an algebra expression this time, but instead of having your numbers, scatter about, right, all your units scatter about everywhere, if you can kind of line them up and group them up to say it's this by this, right, it's gonna be much easier to understand how big of a number we have and how we can regroup them.